Good morning, students. New chapter, insolation. This chapter is about the sun, its heat and energy. The sun creates energy from hydrogen and helium, which are its predominant gases, in the proportion of 3:1. The sun converts huge quantities of hydrogen into helium like giant nuclear reactor. As a result of this process of nuclear fusion, the sun releases great energy in all directions in the form of heat and light. It is a large celestial body having a high temperature. The earth, due to its small size and great distance from the sun, intercepts only a small fraction of energy radiated by the sun. Solar radiation is the only primary source of heat and light for the earth. Insolation is responsible for life on the earth. The sun radiates energy in the form of electromagnetic waves. They travel in all directions from the sun and in the small or short waves. Why short waves? Because it not reaches directly on the earth's surface but absorbed or reflected back by the snow, mountains, peaks or different layers of the atmosphere. Solar radiation is the primary source of heat and light for the earth. Radiation from the sun is made up of three sections. The visible white light, which we see when the sun shines, the less visible ultraviolet rays and infrared rays. The insolation received by earth is responsible for all forms of life on the earth. The circulation in the atmosphere is due to the differential heating of the atmosphere by insolation. The radiant energy from the sun enables plants to manufacture their own food. This forms a basis for the food needed by all other organisms on the earth, like apart from the human being. The circulation of ocean water is also due to the unequal heating of the ocean water by insolation. Solar radiation. Radiation emitted from the sun in the form of a short waves. Means that is heat of the sun. Insolation, the radiant energy received by the earth. That is the heat of the sun received by the earth. Solar constant, the amount of insolation reaching the outer limit of 480 kilometers of the atmosphere is called solar constant. It is the outer limit of Earth's atmosphere, like exosphere. Terrestrial radiation, the heat emitted by the Earth's surface. When the Earth gets heated and it starts releasing the heat, that is the terrestrial radiation. Heating of the Earth's surface is because of insolation. Solar radiation received and intercepted by the earth is known as insolation. You can see I am shown the arrows opposite side also. It means earth is not receiving the direct 100% of the heat but only 51%. Why? Because on the way the heat is reflected by the clouds, snowfields, oceans, water bodies, dust particles, solid particles. So, because of that, only 51% received by the earth. Terrestrial radiation. It is the earth's radiation given back to the atmosphere and space. Means when the earth gets heated, after some time it releases heat. So that heat is known as terrestrial radiation. And these are in the form of long waves, and this terrestrial radiation only heat up our atmosphere. Process responsible for heating the atmosphere. radiation, convection, conduction. So these are the three processes through which our atmosphere get heated. Radiation. Radiation is the form of energy that is transmitted in the form of waves. The energy received from the sun is in the form of short waves radiation, and the atmosphere emits it in the form of long waves. It means that it is a process by which a body emits radiant energy, that is, energy received from the sun in the form of a heat. During the day, the amount of heat received from the sun by insolation is incoming solar radiation, exceeds the amount lost by the radiation. Lost by the radiation means during the night, whatever the radiation has been there, it has because of that the heat has been lost, so that up to that, so the temperature rises till a maximum is reached. Maximum is up to 50 degrees Celsius also. At night the reverse takes place and the temperature falls till a minimum is reached. Minimum is 0 degree or in minus. So that is radiation. Convection. The transmission of heat from one part of a liquid or a gas to another by a movement of particles themselves is called convection. Like near the equatorial region, the temperature is always high. So what happens? The air being lighter, heated up, lighter, rises, spread horizontally and rises higher and higher. Far from the earth's surface, it cools down and starts sinking. As it reaches down, again it spreads, gets heated and ascends. So this is a continuous process of heated up and rising higher, sinking and coming down. So what happened? Convection is responsible for several circulation in the air, and because of this only there is a distribution of temperature on the earth. Convection is an upward movement of a mobile medium, means air rises higher and higher. So this is a upward movement which has been heated by contact with the earth's surface. When it heated up, when it sinks down and come near to the earth's surface, and then the terrestrial radiation heated up this air, again it starts rising higher. Air is therefore said to rise in convection current. Conduction. It is a process by which heat is transformed directly through matter from point of high temperature. Heat passes from warmer to colder substance as long as temperature difference exists. Like, just take an example of iron. Iron means which you use to iron your clothes. When you switch on the button, it starts heating up. After heating up, if you keep it on your wrinkled clothes, what happens? After a second, the wrinkles will be removed. So it means that the heat has transferred into the clothes, and then it has made the cloth wrinkle free. In the same way, just take an example, keep a pan or on a gas stove and switch on the gas stove. What happens? The heat of the gas stove will come to a pan, and you find that pan getting heated up, and if you hold the handle, which is not having a rubber or a plastic, if you touch it with your hand, you feel the heat. So it means that the heat of the gas has transferred into the pan and it heated up. So conduction is transfer heat between two adjacent molecules. When the Earth's surface absorbs heat radiation and warms the air above it, conduction transfers part of the heat to the lower layers of the air. On the other hand, when the surface cools, then overlaying layer, the process of heat transfer is reversed and air is cooled. You can take the example in the summer and winter. If the land is heated up, it transfers the heat, air gets heated up. But in the winter, what happens? When the land is cooled the air which is above the land will also cool down, because the heat is transferring the same thing. So the conduction is confined only to the lower layers of the atmosphere, where air comes in contact with the Earth's surface. Now, this is Earth. It is releasing heat from all the sides. That is the terrestrial radiation, and this is our atmosphere. So because of this, our atmosphere get heated. So this is because of radiation, convection or conduction. And in short, we say it is because of terrestrial radiation our atmosphere get heated up. Differential rate of heating of land and water. Land is solid, hard. So what happens? It absorbs the heat quickly. And water is liquid and always moves. So if we see, the land is warm and water is cool, because it is always moving, so it not always able to get the heat. Just take the example, if the water is kept in a bucket or in an overhead tank, so it is static water, so it will absorb the heat and will get heated up because it is static water. But if the water is in ocean, river, what happens? It always moves. So because of that, it receives the heat, but it's not get heated up. It remains warm as compared to land area. So as the land absorbs the heat, in the same way it releases the heat also. But what happened to water? Water takes time to release that heat because it is remain in a cooler condition as compared to land. So temperature contrasts are great over land masses. They are only moderate over sea and ocean. I think this part is clear to you. We continue the next part. Thank you.